Today we're going to be talking about classifying triangles. So this is 7.3 notes. Make sure you copy the title down. The first thing that we're going to talk about for classifying triangles is the triangle inequality rule. So this rule states that the sum of any two side lengths must be greater than the remaining side length. So that means that we're adding two side lengths together, and when we add those two side lengths together, it must be greater than the one remaining side. And so let's look at some examples here. For example 1, we have 3, 5, and 10. So picture you have like pencils or straws or something like that are 3 centimeters, 5 centimeters, and 10 centimeters. You have one of each. When you put those together, that's going to make your triangle. 1, 2, 3. We're going to see if these three side lengths could make a triangle. And so we're saying that this side is 3, this side is 5, and this side is 10. Is that allowed? So we're going to take the two smallest sides, the 3 and the 5, and we're going to add them together. And that makes 8. And so since 8 is less than 10, we can't have a triangle here because our triangle is going to look like that's 10, that's 5, and that's 3. Notice how it's a lot shorter. So like it can't touch. There's a bunch of empty space here. And even if we push them together, it's going to end up 3 centimeters and 5 centimeters. And so there's still going to be a gap right there. And so when you add the two side lengths together, 3 plus 5, if it's a number that is less than the other side, this cannot be a triangle. So this is not a triangle. We're going to say no. I want you to try to do example 2. Take the two smallest numbers, add them together, and see if it is greater than the remaining side. It has to be greater. So pause the video and try out that example 2. So hopefully you added together 6 plus 10. 6 plus 10 gives us 16. 16 is greater than our remaining side, so that is good. That works out. This would be a triangle. So we would write yes. Now we're going to classify triangles using angles. So we've talked about this before, but we're going to specifically talk about the angles of a triangle. So we've talked about acute angles. Excuse me, now we're going to talk about an acute triangle. So acute angles are angles that are less than 90 degrees. And so this would be an acute triangle because every single side length, 1, 2, 3, is less than 90 degrees. So that makes it an acute triangle. This next one is an obtuse triangle because it has one obtuse angle and then two acute angles. So only one angle is possible to be an obtuse angle. So if you have one, that's going to make it an obtuse triangle. The other two are just acute. This one's what makes it obtuse. Right triangle is easy. You've seen a ton of these before. If it has that right angle there, then it's going to be a right triangle. The other two angles are going to be acute. And this one is a very specific special case here in equal angular triangle, which means that it has 3 congruent angles. All 3 of those angles are going to be the same number. So I want you to try to figure out what that angle is going to be. We know all 3 angles of a triangle should add up to 180. And so if it's the same, I'm going to use the same variable. So x angle plus x angle plus x angle equals 180. So go ahead and try to solve for x. Pause that video now and simplify that equation. You should have combined your like terms. So you got 3x equals 180. And then since that's multiplication, we're going to do division on both sides, divide by 3, and we end up with x equals 60 degrees. And so for the equal angular triangle, every single angle has to equal 60 degrees. Now we're going to classify triangles using sides. So congruent sides have the same length. We use the word a lot in math, that word congruent. So congruent means same. So a scalene triangle, scalene, is going to have no congruent sides. So all of these three side lengths are different numbers. An isosceles triangle has at least two congruent sides. So if you notice there's little red lines, it's because it's saying that these two sides are the same length. They're the same number. So we could say that this side length is 10, this side length is 5, and we would have to say this side length is also 10 because this one and that one are congruent. And then just like before we had an equal angular triangle, we also have an equilateral triangle, which means that all three of our sides are congruent. So if I say this side is 10, then every single side length has to be 10. And then with a scalene, you could say this is 10, this is 7, and that is 5. And so when you are classifying triangles, you're going to classify it by saying what the angle is and what the side is. So you can have acute scalene triangle. You could have a right isosceles triangle. Actually, you can't have a right. Yeah, you can have a right isosceles triangle. So you're going to say one of these, and then you're going to say one of these when you're classifying triangles. So let's go ahead and try to classify some of these. So the first thing we're going to do is we're going to look at our angles. So 60 degrees, 60 degrees, 60 degrees, that is an equal angular triangle. I'm going to probably misspell it, so excuse me, but EQU angular. It is an equal angular triangle. I look at these lines and I see that there are three lines that just have one, and so I know that this is also going to be an equilateral triangle. Equilateral. And that's all you have to do for it. So you're going to classify it by the angle and you're going to classify it by the sides. So if I'm looking at number 5, for example, I see that this is a right angle here, which tells me that this is going to be a right triangle. So we're going to classify it by a right triangle. And then I'm going to look at the sides. It looks like none of the sides match up, so we'll call it a right scalene triangle. So I want you to try out these next couple of problems. Remember, look at the angle and then look at the side length. You should have all of those notes written down. So just try problems 4, 6, 8, and 7. Pause the video now. And here's all of your answers for it. So this one is a scalene obtuse. Scalene because none of the sides match up. Obtuse because that is an obtuse angle. Isosceles, two side lengths are the same. And acute because all the angles are less than 90. Isosceles acute again, same reasons. And then this one is a scalene obtuse because none of the sides match up. And we have one obtuse angle right there. Next, we're going to determine whether you can construct many, one, or no triangles with the given description, and you're going to explain your reasoning. So just like what we did at the beginning of this lesson, we are going to add together the two smaller sides and see if it's equal to or greater than the bigger side. And so for this first one, we're going to take 2 plus 4 and see if it's greater than 5. And it is. So 2 plus 4 is going to give us 6, and 6 is greater than 5. So it is going to give us only one possibility because these side lengths are locked in place. A scalene triangle with two 7-centimeter sides. So We know a scalene triangle, the definition for a scalene triangle is that none of the sides match up. So none of the sides are equal. But then it says 7 centimeter sides. So if we say that there's 7 centimeter sides, that's not going to be a scalene triangle. That's going to make an isosceles triangle. And so there's not going to be a triangle that's possible with that restrictions. Our last question says a triangle with one angle measure of 100 and 1 6-inch side. So we just need to have one angle that measures 100 degrees and then one side that measures 6 inches. And so there's going to be many triangles with those constrictions because this angle only has to be 100 and this side has to be 6. This side can go here, it can go there, it can stop there, and then this side length just matches up with wherever it stops. And so there's 3 different triangles with those constrictions that I drew right there. So there's going to be many triangles because the other side lengths can be varied to change the other angles. And this is your homework. So you're going to go to your textbook, go to page 268, and then you're going to do these practice problems here. So I just wanted to quickly show you how to get to your textbook on the screen. So let me pull this up really quickly. You're going to go to Clever. I've got this handy little button right here that automatically takes me to Clever. So maybe you have that too, but you're going to go to Clever. You're going to log into Clever. And keep in mind, my screen is going to look just a little bit different than yours because you have the student computer, I've got the teacher computer. And so I've got different accesses than you do. You're going to scroll until you see Big Ideas Learning. I favorited it, which means that there's a little heart, so it's on my favorites. Otherwise, you're going to have to scroll down here to practice and click that. You're going to log in with Clever. And then this is where it looks different. You've got a bunch of boxes. I've got this like sliding thing, but you're going to look at that student dynamic ebook. I think it should be on the top left over here for you. Once that opens, you should only have 1 or 2 of these books. You're going to be looking for that course 2 right there because you are in 7th grade. It goes 6th grade, 7th grade, and then 8th grade. So next year you'll have course 3. And then here's your textbook. You can type in the page number and do your practice problems. So if you have any questions, please let me know.